Hi students, in this video I'll be going through the 2023 WA1 paper for Set 1, okay, section B, alright? Okay, so let's start off by reading the question. So Cheryl wants to find out if coffee beans or finely ground coffee powder dissolves faster in hot water. So experimental setups are shown in figure 1.1. So in setup A, she has put some coffee beans in hot water, and in setup B, she has put some coffee powder in hot water. So she's going to stir both at the same time and see which one dissolves first. Alright, so for question part A, they ask you to suggest a hypothesis for this experiment. Right, so hypothesis is basically an educated guess, okay, on what is going to happen. Right, so then after that, once you have made this prediction, you are going to carry out the experiment to test out if the hypothesis is correct or incorrect. Right. Okay, so suggest a hypothesis for this experiment. So if you based on your experience in daily life, coffee powder, okay, is likely to dissolve faster, right? Okay, in hot water instead of directly trying to dissolve coffee beans. Okay, so we should try to angle our hypothesis right along that line. Okay, so something that you could write would be like finely ground coffee powder. Okay, so let's go back down. Okay, so a possible hypothesis that you could write would be finely ground coffee powder dissolves faster in hot water than the coffee beans. All right. So let's write down. So finely ground coffee powder dissolves faster in hot water than coffee beans. Okay, so this would be a possible hypothesis that you can write. So after this, you're going to carry out the experiment and see if coffee powder indeed dissolves faster in water than coffee beans. Okay, so over here in part B, you're asked to state the variable which was changed in the experiment. Okay, so between setup A and setup B, what was being changed? Okay, so the obvious thing that was changed was that in setup A is coffee beans and then setup B is coffee powder, right? So in general, what we can say is that the form of the coffee has been changed, all right? So what we can write is the form of the coffee, okay, has been changed, right? So by form we mean that in setup A is beans, right? Then in setup B is powder form, right? Okay, just like laundry detergent, there's many different forms, right? You have liquid detergent, you have powder detergent, and then you have those that come in capsule form and things like this, all right? Okay, then state two variables which were kept constant in the experiment. So this one basically they're asking you, what are the things that you should not change, right? Such that the experiment will be a fair one. Okay, so if you don't keep this constant, then the experiment will not be a fair one. Okay, so usually such questions, there's quite a number of things that you can write. Okay, so some of the obvious ones will be the temperature of the hot water, right? Temperature has to be the same. The volume of the hot water. Okay, try to use more specific terms like volume instead of saying amount. So the volume of hot water also has to be the same. Okay, then of course the rate of stirring. Okay, if you are going to stir one setup faster than the other one, then the rate of stirring may be a factor that also affects the rate of dissolving. Okay, so things like this. Then of course the mass also of the coffee should be the same. So if you are going to dissolve, try to dissolve 50 grams of coffee beans, then for the coffee powder, the mass should also be 50 grams. Okay. Okay, so you just write down any of those tools, but I'm going to just state all that I've mentioned just now. So the first one will be the volume of water. Okay, volume of water. Another thing that you could write would be temperature of water. Okay, so any of this one, okay, then the thing that I also mentioned will be the mass of coffee. They also use specific terms like mass. Okay, instead of just using general term like amount, right? And then the rate of stirring. Okay, so you just have to state any of these two, okay? Any two. Okay, then of course you can, if you have thought about other things that are logical, right? It's also possible to write down, right? Okay, part D. Okay, suggest the variable that was measured in the experiment. So now you are seeing which one dissolves faster, right? So this will be a matter of time. Okay, so the variable that will be measured will be the time taken for the coffee to dissolve, right? So the time taken for the coffee to dissolve, right? So the time taken for the coffee to dissolve. Okay, let's move on to question 2. Okay, complete table 2.1 on 3 physical quantities and their measurements. Okay, so for this one, they are testing you about physical quantities and their SI units, okay, as well as the instrument to measure it. Okay, so for this one, you can actually refer to page 16 of your textbook, right? Okay, which talks about the SI units, all right? Okay, so physical quantity is temperature, SI unit will be Kelvin, the symbol will be K. Okay, so what will be the instrument that is used to measure temperature? Okay, so it should be obvious to you that it's the thermometer, right? Okay, so the thing is jumping because this is a table, okay? Right, so maybe I have to write outside the table. Okay, so this is thermometer. Okay, okay, then the physical quantity is time, SI unit is second, uh, the symbol will just be S. So the instrument to measure time would be the stopwatch, right? So I'll write it over here. Okay, so this will be the stopwatch, so you put it inside here. Okay, then for the physical quantity, okay, over here you look at the SI unit is kilogram. Okay, so now here we are talking about mass, right? Right, so here will be mass. Okay, and then the symbol, okay, for kilogram, they are talking about the symbol for the unit, so it will be kg, right? Kg. Okay, so it should be written like that, kg, okay, and we'll use the electronic balance to actually measure it, right? Okay, so this one do refer to page 16 of your textbook. Okay, so there are other SI units, right? For example, like length, the SI unit will be meter, and then you will use a ruler, okay, or measuring tape to measure and so on, right? Okay, let's move on to question 3. Okay, so question 3 is a long question, interesting one. So figure 3.1 shows a gold nugget. So there are 3 common types of gold, 24 karat gold, 18 karat, and 14 karat gold. Okay, the carat system is a measurement of how pure a gold sample is. Okay, so in a 24 karat gold, then all 24 parts of the gold nugget are pure without traces of other elements. Means it's a very pure form of gold. Okay, then in 18 karat gold, 18 parts of the gold nugget are pure. The remaining 6 parts consist of other metals. So in 14 karat gold, 14 parts of the gold nugget are pure. The remaining 10 parts consist of other metals. Right, so quite interesting fact. Okay, a density test can be used to determine the purity of a gold nugget. So the density range of each type of gold is shown. Okay, so for the pure gold, the density will be 19.3 grams per cm cube. Okay, for the 18 karat, 15.4 to 15.6. For the 14 karat, 12.9 to 14.6. Okay, so Susan wanted to find out the density of her gold nugget. So she has a piece of gold nugget. She placed some water in a 100 cm cube measuring cylinder as shown. Right, so the initial reading will be, if you see here, before she put in the gold nugget will be 40, 41, 42. Right, so you just keep in mind this. So the initial amount of water in the measuring cylinder is 42 cm cube, right? Okay, so next she tied her gold nugget to a string, and then she lowered it to a measuring cylinder, and then the new volume is shown here. So as you can see over here, the new volume is how much? 47, right? Okay, so 47 cm cube. Right, so based on figure 3.3 and 3.4, can you calculate the volume of the gold nugget? So we know that this is the displacement method, right? Okay, to measure volume. okay, of a irregular shape object. So you can actually refer to page 48 of your textbook to read more about this displacement method to measure the volume of irregularly shaped object. Right, so basically when you put an object inside, it's going to take up space of the water. So the water has no choice but to rise upwards, okay, to take up new space. So the increase in volume of the water, or rather I should say, increase in the level of the water in the measuring cylinder, right? The difference, okay, from the initial measurement will give you the volume of the object that is submerged in the water. Right, so over here we can just do a simple calculation. So volume of nugget equals to 47 cm cube minus 42 cm cube. Right, so this is the final volume, this is the initial volume. So you're going to get a 5 cm cube, right, over here. So this will be the answer, 5 cm cube. Okay, the gold nugget has a mass of 70 grams. Calculate the density of the gold nugget, showing your working clearly. Okay, so you need to know the formula for density. Okay, this one to revise, you can refer to page 52 of your textbook, right? So density is equals to mass over volume. Okay, so I recommend that you always write down the formula, because the more times you write down, the better you can remember it, all right? So the mass of the gold nugget is given as 70 and the volume is 5 cm cube. Okay, so if you do the calculation, you end up with 14 grams per cm cube. Okay, I also recommend that you always write the units in your working, because they will tell you the final unit. See, grams divided by cm cube, that's why it's gram per cm cube. Right, so over here the answer will be 14, right? Okay, so they ask you, determine if the gold nugget is made of 24 karat, 18 karat, or 14 karat gold, and give a reason for answer. So we need to refer back to the table that was given to us. So the answer that we got is 14, right? So 14 lies within this range, okay, to 12.9 to 14.6. That means the gold nugget is a 14 karat gold diamond, right? So let's write down our answer. Okay, so the gold nugget is made of it is made of 14 karat gold. Okay, why? Because its density, okay, its density falls within the density range, falls within the density range of 14 karat gold. Okay, so that is referring back to the table in the previous page. So they in the next part they ask you about some experimental procedure. So explain how the use of a string experiment to lower the gold nugget into a measuring cylinder helps to ensure that the volume reading obtained is accurate. So when you lower it into the measuring cylinder, right? Okay, why do they use a string? Why not just dump the whole gold nugget inside from the top? Okay, so you can think about it. If you drop something from a certain height into water, the water is going to splash, right? So if some of the water, if you drop in without the string, some of the water splash to the sides, right? Okay, so some of the water splash to the sides, then it's going to stick to the side of the measuring cylinder. Okay, and this would reduce the volume of water inside the measuring cylinder instead, right? Because they are sticking on the sides of the glass of the measuring cylinder, and this will actually cause the volume reading to be slightly lower, right? Okay, so this is something that we can write about. Okay, so try to phrase your answer properly, right? So this ensures, so I will write this ensures that water would not be splashed to the sides of the measuring cylinder, thus affecting the volume reading. Thus affecting the volume reading. Alright. So this ensures that water will not be splashed to the side, so the measuring cylinder thus affecting the volume reading. Right? Okay, another student wanted to use the same procedure to measure the volume of a cork. So you should know that a cork is usually used to stopper a bottle, right? So it's actually very low density. Okay, so she realized that the cork indeed floated and could not be fully submerged in the measuring cylinder. So remember, if you want to use this method to measure volume, you have got to ensure that the entire object can be submerged in the water. Okay, because if only half of the object is submerged in water, then the rise in the volume, right, will only be half of the volume of the object. Okay, but at times it's very hard for us to tell really what fraction of the object is floating above or below the water, right? Right? Okay, so in order for this to work successfully, we have to try to fully submerge the cork. Okay, so in order to do that, we will make use of the sinker, right? So this one is also discussed on page 52 of your or 53 or somewhere around there of your textbook. Okay, so you should go and read up and refresh your memory. Okay, so basically, what the student can do is attach a sinker to it. Okay, so that the whole cork can be submerged in the water. Right? So that will be how we angle our answer. So because this is just a 1 mark question, you did not go into too much detail with your answer. Alright, so mainly the main idea is to attach a sinker so that the cork can be fully submerged in water. Right? So what you can write is the student can attach a sinker. So a sinker is basically something that is very dense, heavy, right? So that can bring the cork down. Okay. Cork. So that the cork can be fully submerged in water. Right? Okay, let's move on to question 4. So I think question 4 is the second last question. Okay, so Khairul wanted to find out which type of flame would boil a beaker of water in a shorter time. Right, he heated 2 beakers of water in the science lab as shown in figure 4.1. Okay, so this is talking about the Bunsen burner flame now. Okay, so there's actually an exercise that you should have done in your workbook. So it's a workbook page 27 to 28. Okay, so your teacher should have brought you to the lab, right? Okay, to go through the answer. Right, so do refer to that, okay, to refresh your memory. Okay, so over here you are heating 2 beakers of water. So the only difference is this one is a luminous flame, this one is the non-luminous flame. Okay, so you should be well aware of which flame is more suitable for heating. Okay, so predict which water sample will boil in a shorter time, giving a reason for answer. So the answer would be sample B, right? Because it's heated with a non-luminous flame. And we know that non-luminous flame is actually stronger and hotter of the two types of flames, right? So your answer will be sample B. Okay, because the non-luminous flame is stronger, less hotter, right? Okay, so the next part, okay, figure 4.2 shows the Bunsen burner that was used for experiment. So identify this part, okay? So they want to identify what is this opening. Okay, so this opening, if you recall, is called the air hole. Okay, so it's basically something that allows air, right? Okay, oxygen to enter the Bunsen burner. Okay, so that this oxygen can mix together with the fuel, and with a supply of heat, right? Will be able to produce a flame, right? Okay, explain why we should close part X when leaving the Bunsen burner unattended for a short while. Okay, so if you recall, closing the air hole will not cause the flame to be totally extinguished. Rather, it will cause the flame, right, to turn from a non-luminous form to a luminous form. So if you are leaving the Bunsen burner, we should always try to turn the flame to a luminous form so that it will be visible to people around. Okay, so people will not accidentally come into contact with the flame. Okay, so the answer would be to obtain a luminous flame, okay, which is more visible, which is more visible, right? Okay, let's do the last question. So figure 5.1 shows a pencil placed along a 10 cm ruler. Okay, state the length of the pencil in cm. Okay, so basically what we need to do is we need to find the difference between the two readings, the two ends of the reading. Okay, so over here we have 1.8, right? Okay, so 1.8. Then over here, if you look over here, this should be 8.3. Okay, so 8.3. Okay, so we will take the difference in the reading to find the length of the pencil. Okay, so the length will be 8.3 cm minus 1.8 cm equals to 6.5 cm. Right, so the answer will be 6.5. Right. Okay, over here we have page 19. Okay, so this for the next part, talking about the parallax error, do refer to page 19 of your textbook, okay, to read more about this. Right, so which position A, B, C, or D is the correct position on eye when taking a reading at the tip of the pencil? Okay, so actually just now I already told you the answer already. Okay, so when you want to read any take any readings or measurements, okay, using any instrument, right, you've always got to be you always got to ensure that your eye level okay, is aligned with the reading to be taken. Okay, so over here you need to read over here, right? So you need to align your eye okay, to the mark, okay, to the marking to be read. Okay, so if you align your eye, don't align your eye, right? Basically what you'll do is you'll read some other reading. So for example, if you look from here, then you go to your eye, right? Then you will read over here. Okay, if you look from here, okay, then you go over here, then you will read over here. So the proper way to put your eye will be directly above, okay, or align with the marking to be read. Okay, so in this case, the answer will be C. Okay, so this type of error, okay, actually I already mentioned the answer just now. Name the type of error that will occur if the reading was not taken from the position stated. So the answer will be the parallax error. Right? Okay, so these are some of the possible types of questions that may come out for your WA. Okay, in terms of difficulty level. Okay, but do continue to practice more. Okay, you can also redo the questions in your workbook, etc. Okay, or buy some assessment book and do more practice to apply your knowledge. Right.